My second class of reactions are acid-base reactions. Very, very big class here, acid-base. With acid-base reactions, we have to identify first what is an acid and what is a base, and clearly we're going to react them together. Now, in later chapters, we're going to discover there are several different ways that we can actually define acids and bases. Here's the simplest one, maybe the first one that was used. An acid is simply any compound that when you dissolve in water, it produces hydroniums. Remember H3O plus? That was on your list of polyatomic ions. Hydronium, H3O plus. What you can see is kind of got a water built into it. And it's just got an extra H, and now it's got a plus. Alright, so keep that in mind. A base is defined as anything that when you dissolve in water, it produces hydroxides, another polyatomic. Alright, so that's a pretty simple definition. Let's see an example here of it. Oops. Alright, HCl. If I dissolve that in water, turns out I get H3O plus and a Cl minus. You can kind of see what happens, right? This is separated. I'm going to have an H plus and a Cl minus. The Cl minus is just dissolved in water. It's just out there aqueous. And H plus from here combined with one of the water molecules to give you my hydronium. So anyway, HCl now is defined as an acid. Because, yeah, when I put it in water, that's what it gets produced, my hydronium. An example for the base, sodium hydroxide. Once again, I see that's an ionic compound, Na plus and OH minus. When I put that in water, I know they're going to separate my Na plus and my OH minus, and, well, there it is, hydroxide. When I put this in water, it has produced, just by separating, it's produced hydroxides, and so that's called a base. All right, simple enough definition. Right. One thing to note, and we'll go into this more in a later chapter, but you do have to know it now as well. An H plus in water, if you think about what that is, an H plus, hydrogen only has one proton and one electron. To make it a plus, I strip away that electron, which leaves me with nothing but a proton. H plus, hydrogen with a plus one charge, is really nothing but a bare proton all by itself. Now, a bare proton is going to be highly reactive, a very small charged species, and very quickly it's going to latch onto the nearest water molecule and give you H3O plus. So, in some reactions, it might be more convenient to write it as an H plus rather than an H3O plus, but we're going to take that to mean the same thing. It's simply a proton dissolved in water. All right, so keep that in mind as we go through it. Now, strong acids and strong bases. Strong acids, strong bases, that's defined as something that actually dissolves 100%. So every single molecule of a strong acid that I put in the water, boom, it's going to give me my H plus and for example, my Cl minus in the one above. Same with a strong base. Anything is like that sodium hydroxide, boom, it goes 100%. How do you know whether it's a strong acid or a strong base? There are tables. They're fairly short tables, and that's all we're going to be working with in this chapter, just the strong ones. When we get to later chapters, we'll introduce the idea of a weak acid or a weak base. I can tell you what the definition is. They don't go 100%. And so a strong acid, well, it dissolves 100%. A weak one is going to go maybe only 75 or 50 or maybe only 10. It's not going to go 100. That's the key. So what are my strong acids? There are 6 of them that you need to keep in mind. All right? And here they are. You should start to memorize these now, although, like I said, in a later chapter, you will absolutely need to have them down at that point. So why not start now, right? Br, Cl, and I. That's going right down the halogens of a periodic table. Here's my periodic table. Here it is, Cl, Br, and I. My halogens, the 3 right there in the middle. Right? If you have an H on those are all strong. And so bromide as an acid becomes hydrobromic acid. We'll get to the naming again in the later chapter, but you might want to know these ones at least right now. Hydrobromic, hydrochloric, hydroiodic. Makes sense. Those are all strong. You might say, hey, wait a second, what about the halogens? The other ones, the fluorine and the acetine, are those also strong? Turns out fluoride is not. Hydrofluoric acid is a weak one, so we don't put it in that chart. And there's reasons for it. Again, that's a later chapter. What about acetine? Acetine would be a very strong acid, except when you put it in water, it reacts and actually decomposes in a different way right away. And so, we don't include that one either. But those middle 3, easy to remember, they are all strong. Other ones, nitric acid, HNO3. Notice that's built off of a nitrate. polyatomic. You put an H plus on it and you got nitric acid. Perchloric acid, that's built off of perchlorate. Right? You put an H plus on it, you get perchloric acid. Notice the endings are all IC, 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 so that's kind of easy to do. And finally, sulfate. If you put sulfate is 2 minus, right? Or so you've got 2 H pluses that you need to put on there, and you get sulfuric acid. Now, actually, it turns out only the first H to come off is considered strong. The second one is weak. Yeah, that's definitely a later chapter material. But that first one is strong, and so here we go. Here are our 6 common strong acids. There are a few other ones out there that are fairly uncommon, and we don't need to get into those. So, yeah, at some point get those memorized. Those are your strong ones. If you memorize them now, then it'll make it easier in the later chapter. And I think they're pretty easy to memorize which ones are which. So the book has this picture here of what happens then if I take a strong acid and puts it in water. Here's HCl. HCl as a molecule is a gas. But if I bubble it through water, if I add it to water, here's my H2O liquid, the gas becomes aqueous, and being a strong acid, that HCl aqueous combines with the water to form H3O plus and Cl minus. So first I dissolve it, then it starts reacting and coming apart 100%, and I'm left with this. I'm left with H3O pluses. Of course, there's a bunch of extra water still there, and a Cl minus, everything aqueous. So that last picture is what my HCl would really look like. HCl with no water, it's going to be a gas. When you bubble it through water, it dissolves to form this very strong acid, which we call hydrochloric acid. Same acid in your stomach, by the way. All right. Now that we know what strong acids and strong bases are all about, we can talk about our second class of reactions, which is our acid-base neutralization reactions. See, they neutralize each other. Acids don't react with other acids, but they do react with bases. Same thing with bases. And when they react, you always get the same thing. You always get a salt and water. Water, of course, I know is H2O. A salt, that's just another term for ionic compound. Just like sodium chloride, table salt, made of the ions sodium and chloride. All right, so we get an ionic compound. Let's do an example here. Magnesium hydroxide. I noticed this, if I just dissolve that in water, I would get Mg2 plus and OH minus. It's a base, right? It's a base. Reacting with HCl, I recognize, oh, that's one of my strong acids. And again, if I put that in water, I'm going to get an H plus, which reacts with a water molecule to give me H3O plus hydronium. All right, so these two should react with each other. A base and an acid react to neutralize each other. And the products are, as we talked about before, always salt and water. So over here, they react. The magnesium Mg2 plus is going to now be bound to the other negative. It used to be hydroxide, OH minus. Now it's going to combine with the chloride minus. So here we go, MgCl2. And over here, the H plus, instead of being combined with the chloride, is going to go and combine with the hydroxide. So, well, an H combined with an OH, that's H2O. That's water. All right, so there's my water. Here's my ionic compound, which is my salt again. All right, so typical neutralization reactions. Right? You're getting a base reacting with an acid to give me a salt and water. And you should be able to recognize that. Of course, you have to recognize the acids and bases first. There are lists of strong bases as well. I will put on Moodle a list of both strong acids and strong bases, which are a little more complete than what we were talking about here. But one easy way, I'll just tell you this here, you can start thinking about it. One easy way is any of these group 1s here combined with a hydroxide are going to be strong bases. Right? These guys actually, when you combine them with hydroxides, they're either insoluble or they're weak bases. Right? Nevertheless, if you combine a weak base with a strong acid, you're still going to get a neutralization reaction. Right? Or if you combine a weak acid with a strong base, neutralization reaction. So the key here is an acid plus a base. Right? So I could take any of these. I could take cesium hydroxide, combine it with an acid, and it's going to neutralize each other.